Hello dear students, just I am continuing the exercise 13.1 up to the question 14 we have already solved. Now 24, sorry. So now 25, solution of 25, the finding limit. Okay, 25. So given your function is given. Okay, function is given just like what? Mod x by x, x equal to not 0 and 0, x equal to 0. Mod x by x, x equal not 0 and 0, x equal 0. And we have to find limit x tending to 0 fx. Just limit x tending to 0 fx. Okay, so limit x tending to 0 fx, we have to find mod x by x, x equal to not 0, x equal to 0, and like this. 25 and 26 just like as similar questions. Here, just see, for finding limit, this is here what? At the point x equal to 0, except this point, x equal to not 0 means maybe positive, maybe negative, but x equal to 0 is here. So negative side, positive side both are having in this mod x by x. We have to find x tending to 0 fx. So x tending to 0 fx. For that, we have to find limit, left hand limit. So left hand limit of fx equals to, okay, just we can also write left hand limit of fx at x equals to 0, that is what is given by what? X tending to 0 negative, left hand line 0 negative minus fx, means x tending to 0 negative side, that means just we have to use here mod x by x, mod x by x. Value of the function. Here x is less than 0. Since x less than 0, or we can write x less than 0 implies mod x equals to minus 1. Mod x less than 0, negative value, so mod x, x minus x, because negative value, so should positive, minus x. So here we use, in this case, x from left side, so negative. So limit x tending to 0 mod x equals to minus x upon x. This is equals to limit x tending to 0 minus 1 equals to minus 1. So left hand limit minus 1. Similar, right hand limit you can find. Right hand limit of fx at x equals to 0 is given by limit x tending to 0 plus sign is there. Okay, fx. In this case also we use x tending to, here you can write negative side, here negative side, mod x by positive side, mod x by x. Also positive side, that is x greater than 0, implies mod x equals to x. So we can write limit, because for solving we have to break first modulus value. So 0 plus x upon x is equals to limit x tending to 0 1 equals to 1. So this is right hand limit. So we get left hand limit is not equals to right hand limit. That is, limit does not exist. We get left hand limit is not equals to right hand limit. Left hand limit is not equals to right hand limit, because minus 1 is here, plus 1 is there. Implies limit x tending to 0 of x does not exist. Okay. As a similar process, by using similar process for question 26, you can do it. Okay, just like similar. Here mod x is in denominator. Question 26. Just difference is what? Mod x upon mod x upon mod x, and remaining is same. So by using similar process you can find it just in the denominator mod x. Here limit x tending to, that is left hand limit. This is left hand limit is equals to what? Limit x tending to 0. We use this x by mod x. So just same, by giving same logic, x tending to 0, x upon minus x. X less than 0 implies mod x equal to minus x. Okay, so we can get what? Limit x tending to 0, minus 1 equals to minus 1. Also, same limit right hand limit fx equals to limit x tending to 0 plus x upon mod x. Just same process use 0 x by x limit x tending to 0 1 equals to 1. Then left hand limit minus 1, right hand limit 1. Just give same type of logic. Mod x is equals to x. Okay. So here also limit does not exist. Okay. So just we can get. So we get left hand limit extending to negative side and also is not equal extending to right hand limit. Not equal, that means limit does not exist. Means what? Limit extending to 0 fx does not exist. This was the question 26. Okay, now question 27. Left hand limit, right hand limit not equal as a similar process. If they are not equal, then we know that limit does not exist. Now 27. Question 27 is given limit extending to 5 fx. We have to find fx equal to mod x minus 5. So here given fx equals to mod x minus 5. We have to find limit x tend to 5 fx. X tending to 5. Okay, so x tending to 5 means for breaking modulus here also x tending to 5, just we can find limit x tending to 5 from negative side fx, left hand limit x tending to 5 negative side mod x minus 5. Just use the value of the function. Okay, mod x minus 5. Now limit x tending to 5 here, breaking of modulus. Just see, we know that for x greater than 0, mod x equals to x. Here, just see, this is 0. This is 1, 2, 3, 4, 5, 6, 7. This type of line. 5, this is 0, greater side is this. 5 is this. Now, left hand side of 5, this is left hand side. But here, in this position, left hand side, quantity is greater than x is greater than 0. Okay. So, for x greater than 0, there is 5 greater than 0. This. And for x less than 0, mod x equals to minus x. This is the definition of modulus. But here just see that 5 is always greater than. Its nearer value, the left side of 5, right side of 5 are positive. So we will use this only. This. Okay? Because this value, which is left hand side of 5, also positive. So we will use this value. So here x minus 5. So this is equals to 5 minus 5 equals to 0. Here also limit x tending to 5 positive side fx is equals to limit x tending to 5 positive. Fx means mod x minus 5. Here we will also use x tending to 5, x minus 5. So 5 minus 5 equals to 0. So both limit are 0. So limit exists. Okay, limit exists and we have to write limit is equals to 0. Okay, you can give logic here this because 5 left side of 5 just like 5 is greater than 0, 5 is greater than 0 and here x is left side, so 5 less than x less than 0. Just we can write like this, x is on the x is on the left side of 5 just like this logic. It is 0 and 1, 2, 3, 4, 5, 6, 7, 8. This is a 5. Left side is this. That is x lies here. So it's greater than 0. And here x greater than 5 is greater than 0. Just we can write like this. Okay, here x is less than 5, greater than 0. So here we can write 5 less than x greater than 0. Here 5 greater than 0. 5 greater than 0 implies mod x is equals to x. Here just you can give the logic, 0 less than 5 less than x also is greater than 0 here. Okay, so x 5 greater than 0 and our x is greater than 5 because right hand side x greater than 5, x greater than 5. Here x less than 5, x less than 5, but here 5 greater than 0, x greater than 0. So mod x equals to x. So using this logic we can get like this. So left hand limit and right hand limit are equal as a 0. So we get left hand limit is equals to right hand limit, both are 0 implies just limit x tending to 5 purely fx equals to 0. So this is the limit. Okay. This type type of logic you can give. Okay, for 27 question. Now 28. Question 28 is just see 28 question. What? Here, just suppose fx equals to a plus bx, b minus ax, 4 is less than 1, equal 0. No, just equal. Yes, here. Okay. So 28 question given. Function is given. Fx equals to 3 values are given. A plus bx and 4 and b minus x. This. Okay. So here just given like this, x less than 1, x equal 1, x greater than 1. This is given function. Okay, this is given function. Now for x less than 1, a plus bx. For x equal to 1, 4. For x greater than 1, b minus x. Here a, b are constant. This question is that if limit extending to 1 fx is equals to f1, what are possible values of a and b? So here, if limit extending to 1 fx equals to f1, it is given value of the function at 1 and limit of the function at x equals to 1, then we have to find possible values of a and b. Okay, so for that just find first these two quantity, that is left limit and then f1. So here for finding limit, left hand side and right hand side both are having in this given function, so we have to find left hand limit and then right hand limit. Okay, so here limit extending to 1 left hand limit, fx equals to what? Limit extending to 1 left hand limit, that is extending less than 1, so this a plus bx, that is a plus b, or we can write here equals to a plus b left hand limit, because x equal to 1 is here, a plus b into 1 equals to a plus b, that is left hand limit a plus b, and right hand limit extending to 1 plus fx, so limit extending to 1 right hand limit is b minus x, that is b minus a into 1, this is b minus a, so this is right hand limit. Also f1 equals to given in the function. f1 equals to 4. f1 equals to 4. Value of the function at 1, 4. Now, we are given that condition limit equals to limit x tending to 1 fx equals to f of 1. Pure limit. Pure limit exists. That means left hand limit, right hand limit both are equal. Implies x tending to left hand limit, x tending to right hand limit, both are equal and is equals to limit x tending to 1 fx and equals to f of 1. This is given. So left hand limit what? A plus b implies a plus b is equals to right hand limit b minus a. b minus a is equals to 4 f1 4. All are equal. That is from here. From here we can get two equations. So this is implies a plus b equals to 4 and b minus a equals 4. Now solving these two equations. Solving 1 and 2. You can write this is 1. Just this. Solving 1 and 2. That is adding. Adding means a cancel. 2b equals to 8. b equals to 4. And if b equals to 4, then a equals to 0. We get a equals 0, b equals 4. So these are the values of possible value. Possible values of a equals to 0 and b equals 4 is the other answer. Okay. So here possible values of a and b are 0 and 4. Okay. Now question 29. Take question 29. Here what is given? A1, A2, A3, A and B fixed real numbers and defined a function fx equal to x minus this. What is limit x tending to A1 fx? Given function is what? Given fx equals to x minus a1, x minus a2, x minus a, where a1, a2, a3, an are fixed real numbers, are fixed real numbers. Okay, these are the fixed number and this is function defined. Now we have to find limit x tending to a1 fx first, and second is what here given, limit x tending to a fx, where a is not equals to a1, a2, a3 and so on. a1, a2, a3, a. Means the value of a is not equals to any of this. Then find the limit this and also limit this. So just very simple, because we have to find the limit here extending to a1. So limit will be 0, very clear. Here we see that, limit extending to a1 function, this is equals to limit, just we can write limit extending to a1 and use the value x minus a1, x minus a2, x minus a. Limit extending to a1, product of factors. So you can write x minus a1, limit x tending to 1, x minus a2, limit x tending to a1, x minus a. Clear? Now just see a1 minus a1, a1 minus a1, a1 minus a2, a1 minus a. Just we can find limit like this. Just put x equals to a here. This limit, this limit, this limit we can find. So a1 here, a1 minus a1, a1 minus a2 and so on. They are distinct numbers, so here we see this is 0, a1 minus a1 equal to 0. So we can write 0 limit. Now this limit is 0. First limit is 0 because a1 minus a1, this is 0. So complete 0. 0 is the limit. Okay. Now for finding second part. Here a. Okay. Just use a. A is not equals to any of this. That means this is equals to what? A minus a1, a minus a2, a minus a. This is the value. This is the required limit. Okay? A minus a1, a minus a2 up to a minus a. So very simple. Just you have to write in a proper way. How can we find the limit? By logically. What is the property? Limit can be separated as a multiplication, also in the numerator denominator, and also distributed as a sum product. So remember that. Okay. Now question 30. Okay, question 30 is here also for what values of a does limit exist extending to what? A. What values of a? Okay, mod x plus 1, mod x minus 1. So just see the function given in question 30. what is function given? Mod x plus 1, mod x minus 1. So mod x plus 1, mod x minus 1 and 0. 3 values are given. Okay, and less than 0, greater than 0, equal 0. So here x less than 0, here x equal 0, here x greater than 0. This is given function. We have to find the values of a. If limit x tending to a fx exists, if limit exists, okay, then we have to find, if limit exists, here x tending to a, then we have to find the possible values of a. Okay, so this is our target, possible values of a. So here a is general number, so a can be, a may be equals to 0, because this function is given at breaking at point 0. So we can suppose that a may be 0, may not be 0, that is a may be 0, less than 0, greater than 0. So we consider 3 cases. Here we consider as case first, if a equals 0, just we will take 3 position, a equals 0, a less than 0, a greater than 0, and then in these 3 cases just try to find whether limit exists or not. Okay, for a equal to 0, if a equal to 0, then limit x tending to 0 in place of a, because a will be 0, so left hand limit fx, limit x tending to 0, negative side. Here for x less than 0, mod x plus 1, so mod x plus 1. Now limit x tending to 0, just breaking mod, since x less than 0, because 0, here x less than 0, negative side implies mod x equals to minus x, because negative side, so minus x plus 1. So here we get minus 0 plus 1 equals to 1. Okay, also limit x tending to 0 plus fx, x tending to 0 plus right hand limit, just see right hand limit, mod x minus 1, x greater than 0, here x greater than 0, right hand side. So mod x minus 1, we can write limit x tending to 0, since x greater than 0 implies mod x equals to x. Okay, then what? Here x minus 1, so what? 0 minus 1 equals to minus 1, so limit is minus 1 here, plus 1 here minus 1. Okay, plus 1 and minus 1, that is not equal, does not exist. Left hand limit and right hand limit for this case. Okay, in case this. So you can write so we get for a equals 0, limit x tending to negative side is not equals to limit x tending to positive. A means 0 for 0 implies x tending to a fx does not exist. Clear? For a equal to 0, not exist. For a equal to 0, not exist. Now, just second case, a less than 0, because a is general number. Here a is general number. Case second. Case second. If a is less than 0, then if a is less than 0, then limit x tending to a negative means left hand limit. Limit x tending to a negative left hand limit. So here just we can write it's since in this case x a minus means x less than a. Since x less than a and a is less than 0, a is less than 0. In this case, x less than a, and also a is less than 0. A is less than 0. That is x less than 0 implies mod x equals to minus x. X less than 0, negative. So mod x equals to minus x. Okay? Here x is less than 0. Just we use this. Mod x plus 1 limit x tending to a x minus x plus 1. So minus a plus 1. Clear? So this is minus x. Okay, and limit x tending to what? Right hand limit fx. Limit x tending to a plus same logic x is greater than a. X is greater than a. And a is less than 0. A is less than 0. So, just like this. Okay. So, that means a less than x less than, you can write like this. A less than x less than 0. A less than x less than 0. Because x greater than a, x greater than a, and x less than, because a less than 0, because a less than 0. So this. Clear? So this implies also mod x equals to minus x. Minus x. That is, in this case, also we use which value? X less than 0. So, again we use mod x plus 1. Mod x plus 1. Because just like you can consider this is 0, this is general value a. This is a greater than 0. This side a is a greater than 0. This side a less than 0. This is a equals 0. A equals 0, just we have decided only. A less than 0. That is, if a is here, then its left side is this, right side is this. In both cases, we use this definition, less than 0. And for this, greater than 0, in both cases, we use this. Okay? So, very simple. For writing, logically you have to write like this. Okay, this is equals to limit x tending to a minus x plus 1 equals to minus a plus 1. So, both values are same, left hand limit and right hand limit. Okay, both values are same, that is limit exists. Both values are same. Clear? So we get for a less than 0, limit x tending to left hand limit, limit x tending to right hand limit equals to minus a plus 1. Both are equal. Both are equal. Minus a plus 1 implies limit exists. So in this case, limit exists. Implies limit x tending to a fx exists. Clear? Similar logic for case third, you can, if a greater than 0, then limit x tending to a left hand limit, x tending to a left hand limit mod x minus 1. Just we will use this. Here a greater than 0. Greater than 0 element is here. That's why we are using this. So this is equals to limit x tending to a. Here mod x equals to x minus 1. Since a greater than 0, here x is less than a. So x is less than a and a is greater than 0. So a is greater than 0, that is this. A is greater than 0. So 0 less than x less than a. Here a is greater than 0. So x, this implies mod x equals to what? Plus x. Mod x equals to plus x. Because x greater than 0. So here a minus 1 is limit. Similarly, and also limit x tending to a plus fx. X greater than a. X greater than a. So limit x tending to a plus. Just we will use this value because a greater than 0. And x is greater than a. Since x is greater than a is greater than 0, implies mod x equals to x. X is greater than a, and greater than 0. So x greater than 0. This. So we can write limit x tending to a x minus 1 equals to a minus 1. So here we see that also limit exists for a greater than 0. Clear? So finally we can write what? So we get limit x tending to a negative fx is equals to limit x tending to a positive fx equals to a minus 1, implies limit exists x tending to a fx exists we get for a greater than 0. Just we can write for third case, for a greater than 0 limit exists. Thus we get limit x tending to what? X tending to a fx exist for all, we can write for all values of a except a equals to 0. For all a except a equal to 0. That is, for all a is not equals to 0. For all a not equals to 0 exists. So value of a, possible values of a are what? Except 0. All the values are possible for existing of this limit. Okay. So this is question 30. Now question 31. Just I will discuss. It's very short. 31 and 32. Okay. So question 30. If the function satisfies relation fx minus 2x square minus 1 equals to pi x tending to 1, then find the limit x tending to 1. So this question is simple. Just write in a logical way, then you can get the limit of that function. Okay, here if a function satisfies what? It is given that fx satisfies limit x tending to 1 pi. What? X tending to 1, fx minus 2, x square minus 1. Fx minus 2, x square minus 1. This is given. Function fx satisfies this relation. Clear? We can solve it. We know limit distribute in numerator and denominator. So just distribute it. Limit x tending to 1 fx minus 2 numerator and limit x tending to 1 x square minus 1 equals to pi. So limit x tending to 1 fx minus 2 equals to pi into limit x tending to 1 x square minus 1. Just transfer to right hand side. So here distribute limit x tending to 1 fx minus limit x tending to 1 2 equals to pi. Here we can find the limit because it's x equal to 1, just put here, you can get the value. So 1 square minus 1. After putting the value x equal to 1, 1 square minus 1. So here limit x tending to 1 fx minus a constant. So limit is what? 2 equals to pi into 0. So this is equals to 0. Thus we get limit x tending to 1 fx equals to, transfer to right hand side, 2 is the limit. Limit x tending to 1 fx equals to 2. So simple process. Just distribute limit in denominator, then transfer in right hand side. Just do distribution limit and you can get final this value. Okay. Now last question is 32. Okay. So question 32. Here given fx equals to mx square plus n, mx square plus n, and nx plus m, and nx square plus n, nx square plus n. Three values are given corresponding to x less than 0, x greater than 1, x less than 0. Here 0 less than equal x less than equal 1. 0 less than equal x less than equal 1. And x greater than 1. And here x greater than 1. This is given function. Okay. And for what integers m and n does limit x tending to 0, x tending to 1? X tending to 0 and x tending to 1 exist. For what integers m and n? We have to find the values of integers m and n for which limit x tending to 0 fx and x tending to 1 fx exist. This is our target. Okay, just we have to find the value of m. What may be the value of m and n as integer? For that, these two limit exist. So for existing of this limit, left hand limit and right hand limit, also this left hand limit and right hand limit should exist. So first case. Now for existence of limit x tending to 0 fx, we should have limit x tending to 0 negative left hand limit and x tending to 0 right hand limit. Okay. For this, just find left hand limit and right hand limit. So we see that left hand limit x tending to 0 negative fx, limit x tending to 0 negative this less than 0, mx square plus n, mx square plus n, x tending to 0 left hand limit, left side, just put the value from left side of 0. So this is equals to x mx square plus n. So this m into 0 square plus n equals to n. Okay, so left hand limit is n and right hand limit x tending to 0 plus fx. Limit x tending to 0 from right side. X is greater than equal 0. So this is right side of 0. Nx plus m. That is n into 0 plus m equals to n. So left hand limit and right hand limit we get as n and m. Okay. So for existence, for holding this, for satisfying this, n and m should equal. Thus, for existence of limit x tending to 0 fx we should have m equals to n. Okay, m equals to n. So we can write for existence of this we should have m equals to n. As a similar process for 1 you can write. Left hand side of 1 is this, right hand side of 1 is this. Okay, so same process extending to 1. For existence of this limit we should have what? Left hand limit at 1, right hand limit at 1. So find left hand limit at 1. Left hand limit at 1, that means left side of 1, nx plus n. Nx plus n. This is equals to n into 1 plus n. That is n plus n. Similarly, right hand limit of 1. So right hand limit of 1, this is right hand limit, right hand side. So nx square plus nx square plus n. So x n 1 square plus n equals to n plus n. So we get n plus n. Okay, so n plus m, n plus 1 both, they are always true for all m n. Thus, for existence of x tending to 1 fx, m and n may be any integers. Thus, for existence of this limit, second limit, m and n may be any integers. It is for all integers m and n limit exists. That is, for all m n limit x tending to 1 fx exist. Okay, so this is the ending of the exercise 13.1. Okay, do all these questions. In your copy and also solve all examples and do complete this exercise in your copy and send me 2-3 questions for your attendance. Okay.